Hello again, YouTube. So just to follow up on my Arduino control of my wood stove, this little circuit controls the damper motor position, or the damper position, and you can set the temperature on the stove. I'll show you to three settings: 180, 220, 260. And you can see the temperature of the stove right now is 110.75 degrees Fahrenheit. Damper position is 0.00%, and the 260 degrees is what I call the high setting. So I'll switch it back to the low setting of 180 degrees. It just goes down this little wire. The temperature sensor that's right in there is called a TMP36. You can Google it. It's probably $1.50, or I don't know what they cost, $5 maybe at the most. And that's the input to the processing board here. It's called a Mega 2560. That's the name of it's upside down. It's made by, this one's I guess made by Elegoo. If I turn the camera upside down, maybe you can see the name. And it's got a breadboard for the other components, and then I just attached a display to it. And this is the output wires that go into the back of the stove and then go to the servo down here. This is the stove it's attached to. This is our medium-sized Regency freestanding airtight. And you can see there's the Regency name. And I just installed the components just inside here. And there's metal plate. Screws on over top with 4 screws. I just took it off temporarily to put the parts in. And you can see there's the little servo, and the rod goes straight up and attaches to the damper like I showed you. And here's the damper rod over here, the manual damper. Here's the manual damper. And now you'll see the automatic damper. Whoops. And that's how the automatic damper works. What it is, it's just a servo motor attached to a block of wood in the bottom of the thing, and then you can see that that attaches right up there. So for right now, you can see, I'll just show you the stove is at 70, or the damper is set to 70.6% closed. The stove is set on a low temperature of 180 degrees, and the actual stove temperature is 172.98. So it's floating around the set point, and it's working perfectly. So how it works is, servo motor is set for 170 degrees of travel. We'll put it at the full closed position, and that will close the damper at 100%. So then it has 3 settings as it approaches the set temperature. When it's 10 degrees below the set temperature, it goes to 120 degrees of servo rotation, which translates into 70% damper closed. And then as it gets to within 5 degrees of the set point, it goes to 130 degrees of servo rotation, which translates to about 82% closed. And then when it gets to within 3 degrees of the set point, it closes to 87% damper closed, which is about 140 degrees of servo rotation. And then finally, when it hits set point, it goes to 170 degrees of servo rotation, which is 100% damper closed. And it's working really well. Okay, just a few things to add. The damper door that's being closed by the servo motor is a little piece of metal I had to make up for this particular stove. So for your stove, depending on what type of stove you have, you'll have to rig up your own automatic override that can influence the normal manual damping system. And the code I'll post on a pinned link below in the comments at GitHub. So if you want to download the code, you can do that and set up your own stove, depending on your make and manufacturer, with your own hardware, and it works great. Over and out.